So from the last video you would have seen that there was a temperature, that this temperature is shown at the separator. So if you can see from here, the temperature of the gas is 54.39, pressure is 1.282, and the molar scuff are 59.85, and some of the molar scuff, they have been removed in the form of condensate and water at the bottom. This gas from the slug catcher will go into the inlet cooler. So that I have added from here, that is the cooler sign. So I have pulled that cooler sign to here. So if you add up the slug, if you click on the cooler and add the inlet, you add the condensate, the gas from the slug catcher. So now the energy stream will be the Q2. I am going alphabetically order or ascending order. I am just using the Q as a heat stream that we usually do in the chemical engineering. The outlet is gas from inlet cooler. So now, as you can see, when I haven't given this number, so it was saying that you need the outlet. So now it will also direct you that what things you are actually missing out. So it says unknown delta P, that there is no delta P is given, but because we are using this inlet cooler just to cool down the gas, so which means this cooler will be the temperature driven cooler. That means that we have to give the temperature, outlet temperature for this stream. So there are two options. Either you can go direct to the parameters and you can let them know that this is the delta T that we are going to have. The other option is that you go to the worksheet and you add up the temperature. So basically, if you add up a temperature of 45 degrees Celsius, that is the minimum inlet temperature to the MRU unit, that is the mercury removal unit. So once you have given that temperature, the pressure you have to give, you don't have to give the pressure, and you can see from here that the vapor phase is, you are going to have it completely 1, so it will automatically calculate the pressure itself. This is one option. The other option you can use is that you just delete this one. In most of the cases, you know that how much delta P will be across the cooler. If you go to the properties or the design and then to the parameters, and you can give the delta P here. So I'll be giving the delta P, or I'm considering that there will be a pressure drop of 50 kPa across the inlet cooler. So if I click that one, so you can see at the worksheet conditions that the temperature is 45, that 50 kPa pressure that I have given is, that has been reduced to 1.277, 10 raised to the power 4, and here the vapors are 0.9993. Now I will see that what are the changes going on till now, how the mass flow, how the molar flow rate, temperature and pressure are changing along with the simulation. If I see from here, the molar flow is almost same, that is 59.85 that we were actually having here, and the temperature has only changed and the pressure based on our requirement. Now the gas from the inlet cooler has been taken off. Another thing I would like to see in this stream would be the composition. That is the most important part, that what things have been removed and what things are left. So if I can see from here, I can see a very small amount of the water is present. Then there is small amount of the carbon dioxide and the nitrogen are there inside the material stream, and we are looking that the methane is getting purified purified, so it is having a more and more concentration here in the mole percentage.